Hello viewers, Assalamu alaikum. Hope that you are well by the grace of Almighty. Today I am here to discuss a solution technique of a differential equation. For these issues or purpose, I have taken a differential equations to solve.
Press the bell icon on the YouTube app and never miss another update.
Here the equation is solve x square y minus 2x y square dx minus x cube minus 3x square y dy is equals to 0. This is given question. We have to solve this question. So first of all, this is noticeable that dx dy, since these two are the differential operator, so this is a differential equation. This is like m, that is m dx. This is like n, that is n dy is equals to 0. So this is a pattern of differential equation. Let m is equals to x square y minus 2x y square and n is equals to minus x cube minus 3x square y. This is, after that I am differentiating m partially with respect to y, and we will get del y of m is equals to del y x square y minus 2x y square, and then it will be x square minus 4x. Because of here x is a constant term, x we have taken out, and del y of y is 1 minus 2x is a constant term, and if we differentiate to y square, then it will be 2y, then it will be 4, 2 to the 4 x y. Okay, and del n of x is equals to minus del x of x cube minus plus, here this minus plus, so 3y del x of x square, then it will be minus 3x square plus 6xy. So have a look here, del y of m is equals to x square minus 4xy, and del x of n is equals to 3x square plus 6xy. So these two terms is not equal. Here del y of m not is equals to del x of n. So this given differential equation is not exact differential equation. If it is not exact, then we have to test whether m x plus ny, that is, here m is this term, so you have to multiply this term with x, so it will be x cube y minus 2x square y square plus this plus n is this term, so multiplying by y, it will be 3x square y square and minus x cube y. It will be x square and y square. So this is not is equals to 0 actually. Is it 0? No. This is x square y square. It is not 0. We have discussed a solution technique in my previous lecture, that if this is not exact, that is del y of m not is equals to del x of n, and mx plus ny not is equals to 0, then our integrating factor will be if is equals to 1 divided by x square y square. This is our integrating factor. To make the differential equation exact, we have to divide by x square y square of our given differential equation. That is, we will get x square y square minus 2x y square divided by x square y square dx minus x cube minus x cube minus 3 yx square dy divided by x square y square is equals to 0. Here x square y minus 2x y square divided by x square y square dx minus x cube minus 3 yx square dy divided by x square y square is equals to 0. Then if we distribute this term among these two terms, then it will be x square y divided by x square y square minus 2x y square divided by x square y square dx minus x cube divided by x square y square minus 3y x square divided by x square y square dy is equals to 0. Then it will be 1 divided by y 2 divided by x, because of this y and this y cancel here, x square and here is x, so it will be 2 divided by x, and this dx minus x divided by here x square and there is a x cube, then it will be x and there is y square minus 3 x square cancel divided by y, because of there is a y and here is x y square, and dy is equals to 0. Now this is m and this is n. So if it is divided by the integrating factor which was non-zero, we have to just integrate here considering y as constant and here x free terms. So we can write down here integration y as constant, that is 1 divided by y minus 2 divided by x dx, and here x free terms. There is x, so it is not free, so this is free. This minus and this minus will be plus. 3 divided by y dy is equals to 0. After that, we can write down the next slide. I am writing here, since 1 by y, that is y is constant, we can take it out, so it will be dx minus 2 is constant, we can write down like this pattern, dx plus 3 is constant, 1 divided by y dy is equals to 0, and 1 divided by y into this is x, because of integration of dx is equals to x, and this is 1 divided by x. If we differentiate this x with respect to x, we will get 1, so we can write down 2 ln x here, similarly 3 ln y, and since we have completed our integrations, we have to put here the integrating constant here c. Now ax divided by y minus 2 ln x plus 3 ln y plus c is equals to 0. So this is our desired solution of the given differential equation when the differential equation is not exact but m x plus n y not is equals to 0. By using this technique, we can easily calculate the non-exact differential equation that obey these rules that we have already discussed. If you think this video is helpful to you, please subscribe my channel, like this video, share it to your friends, and stay with us. Thank you very much.
Press the bell icon on the YouTube app and never miss another update.